Hello and welcome back to my channel, everybody. This is going to be what I think will be the last lesson in the caster wheel assembly for grade 12. And I've updated the module descriptor here to reflect a lot of the work that we have done in this project. So we had started with creating 3D models of the following parts. We created a D-size drawing layout to include the post and third angle projection, the bracket in a top, front, and right side orthographic view, a view of the shaft in third angle projection, plus a detail view, which is something new. The wheel as a third angle projection sectional view, the bushing in third angle projection, and we did not draw that retaining ring, which was part 6. We imported one from the Autodesk Inventor Content Center. And we also created an assembly, a third angle projection sectional view, plus a detail view, and we cut through the post and center of the wheel assembly. So when views are complete, begin to dimension detail the parts, and that's something we have already started as well, and we're pretty much finished. All we need to do is basically tune it up a bit and look at what we need to do here. So one minor thing that we haven't done yet is label all the detail views on the drawing sheet, and a lot of these dimensions have single, I'm going to say 0 precision to them. So there's no decimal places on these numeric values, except some of them do. For example, this groove in the post is shown as 7.5. My drawing shows it as 8. The peen hole in the bracket, 14.5. Mine is rounded up to 15 because we basically edited all the dimensions just to show 0 precision. But we need to create some new dimension styles to modify some of these dimensions, which is fairly simple to do. So one of the things I'm going to be doing is scanning through this, and I've already set up my standard and change the dimension, but I need to do the rest of them. So we're going to click into here and we're going to take a look. So I've also run the peen diameter that goes into the bracket. Now you didn't see me run this dimension in my previous lesson, but I'd like you to run this dimension, and we're going to be editing this one, plus this dimension, or this leader, we're going to flip this around. So I want this to say the opposite, 1 times 45 degrees. Like that, because that's what we did everywhere else. That's what we did here on the shaft, here for the rib, and so on. So we're just going to keep that consistent. Now, when you run this dimension, and I will run it again just because I want to mention something important. So in annotate dimension, you can select just this vertical line and pull that dimension off. And notice how it includes the diameter symbol for you. So we're going to right click, left click OK. We're going to just turn this like this. And I didn't have the luxury of doing that for this groove diameter because I couldn't select that. That basically just that line by itself. It forces me to select this one, and I don't want it. So I had to manually insert a diameter symbol here. Anyway, so I don't need any more dimensions right now. I'm going to turn that off. But what I'm going to do is right click this dimension while I've exited general dimension and go to edit dimension style. New dimension style. And what I've done here is I've created a couple of other standards. I call this one's not included in Inventor. It's called decimal 1.1 precision and decimal 2.12 precision. So if I select one of these two, it's going to place that dimension value appropriately where I need it to be. So for example, if I select this dimension and I select from my list decimal 1.1 precision, it's going to update that to be 14.5, right? So coming over here, I can do the same thing. Click it, set that to decimal 1.1. Now, how do you create your own dimension standard option, right? So what you can do is right click, go to new dimension style, and you can just type the name of it up here. So for example, if I was to do this again, it's just going to create the same thing but 0.01. So what you want to do is just come down here to precision and make sure you've selected 1.1 from this list. So in your case, it'll probably read as 0. Just change this to 1.1 and hit OK. Right? And as you can see, that's not going to change. If I wanted to create a 2 decimal place precision, I can right click, hit new dimension style, and I can select this one, and like this is the other one I created. I can just type the name of it, right? I can say decimal 2.12, and it's gonna basically rename it. It's gonna add a 02 on the end because I already made these earlier when I wasn't recording. But again, change the precision from 0 or from 1.1 to 2.12 and hit OK and see what happens. Now, this is not something we want here. So we're going to take this and we're going to put it back to here. Now, why do you need to have a 2 decimal place precision option? Well, that is for the shaft right here. Because this groove is rounded up to 1, but it should not be 1. It should be 0.73. So we're going to select this one, place it, and that's exactly how it should look. Now on the iPad, it also shows a prefix of a 0. Don't worry about a prefix. It's pointless to include because I think it's well known that there is an imaginary 0 in front of a decimal place like this. So we're just going to leave this like this. This one needs to be fixed too. This one needs to be changed to 6.4 diameter. The shaft is okay. Now this one needs to be changed, and it should say 8 on your drawing. I've already gone ahead and done this. So I've already changed this one to 7.5. So don't forget to do this one. So just because you don't see me do it doesn't mean you don't have to do it. The bushing is fine. The wheel is fine. So is the assembly. We're going to come over here to the bracket. And this one here, don't double click. So just click once. The thickness is shown as 2.38. And the key is set to 1.1 precision. Okay, so that should be everything. So we've done this, we've done this. We're going to take one last look around and make sure I haven't forgotten something. Okay, so we're good. So another thing that we can do, I started this yesterday and I never finished it, was label all the parts in the detail views. So we're going to double click this one, we're going to block it off, and we're going to make this as large as we can go. Hit OK. And we're going to do the same thing for every detail item. So this one is 3 shaft. Some people may call this overkill, but this is actually something that needs to be done on all assembly layouts like this. This is something that I had to do when I worked in industry as well. And there, we would also even include the material underneath in smaller text. even though the parts list says all that, but they just don't want there to be any confusion. And I keep forgetting to make these big. All right, so this we're going to pull down. We're probably going to pull this up a bit. Just so we're not crowding it. That's a little crowded. We're going to move this down a bit. We're going to put the bushing here. We're going to try to put these between the views underneath. This, the distance between the wheel in the front and right side sectional view should be similar to what we see in the assembly. So we have our detail view here, a section view of the keyway to dimension it, and oh, and we also forgot, or I also forgot this wheel. Block it off. Okay, and that should pretty much be it. One last thing you can do is look around and make sure that dimensioning spacing is very consistent. You don't have some dimensions sticking way out and some way close. So for example, this one could be moved out a little bit more to suit what we have here. This is a little close, so we're just going to bring it up a bit, give it a little more breathing room. What we see here looks pretty good. It doesn't have to be exactly the same between item to item, but it should be fairly close. Right? When we look at something like this, the spacing should be consistent. So what we could do with this one is bring it over to this side. Like that. Then we can kind of keep this one all on one side in line with the 35 and the 22. This could come down a bit more. Add a little more breathing room. And that's basically it. So if I could just say one last thing about this, and this goes for anything in life. You get out of it what you put into it. So if you put a lot into this, and I think you've watched all the videos, you see me put a lot into this. I don't need the marks, but you know, I need you to do the best you can. So I really want you to take these drawing files seriously and basically put the same level of commitment I've put into creating mine as I've used to kind of teach you the right things to do. So I'm going to end the video here. And that's all. I think that's all there is to this. So I'm going to hit save. And there's your last task to finish this up. And I'm going to be creating a Dropbox for this. And when you Dropbox all of the components, you need to Dropbox everything. So you need to Dropbox all 5 3D solid models that you created. You need to Dropbox the assembly file, the .iam. You need to Dropbox the .iam, which is this, the drawing assembly, and you also need to Dropbox a PDF copy of this. So how that works is you go to File, go to Save As, and go up to Save Copy As, and then from this list, select PDF. I don't have any PDFs in here, so it appears empty. And then hit Save. And this is going to generate the PDF in that file. So basically, you have a total of, so you got 5 items, you got 1 assembly, 1 drawing, 1 PDF. So you have 8 files that you need to send me in the Dropbox. So I'm going to open that up in a day or so and let you start inserting that. So until we talk again, good luck, take care, and the next time we speak, we should be looking at advanced solid modeling techniques. Take care for now.